Okay, we're back. Yeah, this is going to be lecture 2. This is going to be titled If, Ands, or But, Or's Buts. It's hard to make a pun every time, but I try. Let me share my entire screen. Definitely not going to regret that. Okay. So, yeah, welcome to lecture 2, If, Ands, or Buts. So, a couple of things. The first lecture, you will note that I did not have slides. This is because I made slides for this class a long time ago, and unfortunately, they were lost, and that is sad. But going forward, I'm going to be remaking the slides. This time, I didn't get through all of the slides, but future ones, I will have more. All prior lecture recordings will be on YouTube. I will also be releasing the slides on Google Drive, and this link is an actual active hyperlink that'll take you to the playlist that all the slides will be or that all the lecture recordings will be posted in. The first project is going to be assigned today. If you did not, or if you had issues setting up the environment in the first lecture, you can either talk to me or talk to Himanshu, who has done this probably about a dozen times now. And also, this class has grown a shitload. So when I was first asked about this, it was going to be like 1 to 4 people. And I think we now have about like 10 to 15 following along. And I imagine it's going to keep growing because I've gotten more and more requests even in the past week. So with that being said, I wanted to cover the plan for what's actually going to be going on. So this course is going to be sort of like an intro to programming through Java course. It's broken up largely into 3 sections, which is going to be the basics of Java specifically, and then also the basics of object-oriented programming, and then a couple of bonus items that we're going to be covering, things like recursion or inheritance, which is part of object-oriented programming. But yeah, anyways, we'll get there, and we'll also probably get into some file I/O stuff, so how to read and write data from a file, and then we'll go elsewhere from there. So at that stage, you then have to be asking, you have to be asking yourself, what do you actually want out of this course? So once we have completed this course, there are going to be 2 paths. One is the more CS, I want to be a software engineer, I want to, build large programming systems. I want to work for a startup or for Amazon or whatever, right? That's what I want to do. And I'm going to have a data structures course that is going to be sort of like the follow-up to this one that is going to take us through, the next stage. After data structures, there would be a handful of others, but which we can cover, as we get there. But just to let you all know what is next, that is one of our options. And the other option is machine learning engineering training. So this is going to be a more real-world practical focus on machine learning engineering. So ML engineering is a field that is becoming increasingly popular, where you are basically a software engineer that also knows how to program machine learning models. The main difference is that, unlike software engineers, you don't need as big of a breadth of understanding of a lot of CS concepts. And thus, I'm going to break it off into its own separate track early, as to not kind of waste a lot of your time. Now, you're welcome to take both. I don't mind. But yeah, I'll probably be teaching 2 courses starting in January-ish. So yeah, that's going to be what's available. Those are going to be a little bit faster and a decent bit more intensive. So there's going to be more projects. There's going to be more classes, and we're going to go through the material a little bit faster. But yeah, those are the options. So we'll figure it out. Getting started on today's subjects, we're going to be doing some Boolean logic first. So in the last lecture, we talked about different types of variables, and we talked about ints and strings and characters and floats and doubles, things like that. And a lot of those were very intuitive, but one of them was pretty different, and that was the Boolean. So what actually is a Boolean? Oops, I have the slides out of order. Oh no. Okay, hold on. Let me fix that just for my sanity here. I don't know why those slides are out of order. This should be back up here. Escape, and I go back up here, and then I hit slideshow. Okay, they're now back in the right order. So what is a Boolean? Booleans are either true or false, and that's it. They can only hold two values. Somebody in the last class asked if it was a bit, and it is basically like a bit. It's either a 1 or a 0. That is a good way to think about it. It's not actually stored as a bit for a bunch of complicated reasons, but yes, it is effectively a bit. And why do we care? So the thing is, Booleans are actually used in a lot of places in coding, but they're one of the few variables that you're almost never going to see outside of a program itself, right? We are typically going to use them in conditionals and loops. They are used in other things as well, but we're not really going to get into that today, just because they're pretty niche. But yeah, that's basically the whole concept of a Boolean. So how do you get a Boolean? You can either write true or false in your code, or you're going to, more likely than not, you're going to get it from one of these comparison operators. So there's a couple of different comparison operators. The main ones that we're going to care about are greater than, less than, and equal to, right? So they are basically what they say on the tin. Something important to note, though, is that they are not greater than and less than are not symmetric. So something cannot be greater than itself. Something can also not be less than itself. Somebody's trying to join the call. Give me 2 seconds to admit them. Meet. Okay. Welcome. So that's going to be either greater than, less than, or equal to, and you can also combine them. So the way, given the two examples I have on the bottom, the way that we would read those is 3 is greater than or equal to 3, which would be true, because 3 is equal to 3. And then 3 is less than or equal to 5, which is still true, because it is less than 5, even if it's not equal to 5. I've got some more examples on the right there. Just those are actual screenshots from JGrasp. So you can test this out yourself in the interactions panel, which I'll be covering in just a second. So yeah, that's demo time. Okay. So I first need to pull up. Oh, now the whole internet has my Wi-Fi password. Oops. That's okay. See, I told you I was going to regret that. All right, so this is exactly where we left off, in the last class. We started to get into loops, and you may remember that we had this little conditional here, right? So what this is talking about, this is a while loop, which means it's going to loop between the curly braces defining the while loop, in this case between lines 38 and 41, as long as the condition is true. So this condition evaluates to a Boolean, right? This will literally in code get replaced with either true or false. However, given our example here relies on a variable, this will be updated every time it gets checked, right? So if we actually, if I include a breakpoint here and I run you through to the end, and I hit, nope, not that one. I hit this one. So, in this case, we have our num2, which is currently equal to 15, right? 15 is less than 25. So this is actually going to be replaced effectively with true for this loop. And if I step down into it, you'll notice because it is true, we're going to enter into this, or into the loop. So we're going to print out num2, which should be 15, right? And it is, so that's great. And then we're going to add 1 to num2, right? That's what this is doing. Num2 equals num2 plus 1. So we're going to update the value of num2 to be equal to the current value of num2, which is 15, plus 1, which is 16. So we're effectively saying num2 equals 16. And you'll see on the left side here that num2 does, in fact, update to 16, which means it's still less than 25. So we enter the loop, we print that out, and we're going to keep doing this over and over and over again until we hit 25. Now that num2 is actually equal to 25 after this, it checked if 25 is less than or equal to 25. This evaluates to false. So it does not enter this loop at all, and instead jumps to the next executable line, which is on line 43 here. So that's why you'll notice it did not print num2 is 25, even though num2 is actually currently 25 in code. It does not print it because we currently have this set as num2, or our condition is checking if num2 is less than 25, not less than or equal to. And if I were to update this to less than or equal to, we will, where's the end button? There's the end button. We will get a slightly different result. So we do actually see 25. That's it. Okay, before I move on, any questions on this portion? No? Pretty straightforward? Okay, awesome. So I did just briefly want to interrupt you guys just to show the interactions panel in JGrasp, which is kind of cool. It lets us do some fun things. So interactions panel is basically like a main method that you get to experiment with. So you can define variables over here, like int a equals 5, right? And we'll actually get integer variable up there equal to 5, right? We can set it equal to 100. And this is mostly just used for testing or debugging, but it's also very helpful if you want to check something, right? So if you want to check what some code evaluates to, you can actually just run it in this interactions panel. So in my case, I've tested if 3 is less than 5, which it is, right? We can test if A is less than 100, which it's not. Oh, sorry, I had 1. Oops, A is less than 100. Apologies, I can't type, which is not. False. But yeah, so this can be kind of fun. Just make sure you hit end before you leave, otherwise you're gonna get some weird errors. And that's mostly just because JGrasp is old. And that's okay. But yeah, time to move on to conditionals. So I'm actually gonna erase a lot of the code that we had previously. And you're more than welcome to keep it or restart if you'd like, but I'm just doing this to keep my workspace clean, mostly for the recording. So we can start off by having an int, which I'm going to call num. I'm going to set it equal to 5, right? And a lot of times when we're writing programming or programs, we don't necessarily want the program to do the same thing every time, right? So sometimes on your, especially when you're getting feedback from a user or input from a user, depending on what the user does, you want to perform a different action. You can think of a very simple explanation of, if a user clicks on a button in a web page, or if they click on, the forward button versus the back button, you want to do two different things, right? So how do we check for variable input? Well, we have variables, but then we need to actually take different actions in response to them. The way that we typically do this is with what's called a conditional statement or an if statement. So you write the word if, and then we put our conditional. And this needs to be some piece of Boolean logic in here. Boolean logic being what I discussed earlier in the slides, that goes through, that gets evaluated to either true or false, and it will enter either the if condition or it will not. So first we can test if, oops, excuse me, I can't type. Num is equal to 5, which in our case, we know it is because we set it right above. Naked system.out.println. Our number is 5. Yay. Right? And if I run this, it will print. If I, however, change this to 6, this entire section of code between lines 5 and 7 here will just not get print, or will not get run at all. So we won't print this, we won't print anything. And in fact, our entire execution stack just appears to be empty. With every else, or with an if, can also come an else. So an else is sort of like saying, if the if block does not run, we want to run the else, right? So in our case, we could say system.out.println, our number is not 5. Right. And in our case now, we're going to print our number is not 5. And if we run the debugger, it's pretty easy to see why. right? Our num is set to 5. Or our num is set to 6, excuse me. So this would evaluate to false. So we're going to completely skip the if block and instead, because we skipped the if block, evaluate the else block. Any questions on this? No, pretty straightforward. Okay. N is down here. Sorry, I'm coming from a different IDE. Yes, VS Code. All right, now, can anybody tell me what the following code is going to produce? And if you're following along in the recording, feel free to pause and see if you can guess. Oh, welcome, Lena. Okay, our number is 5. Alrighty. Can anybody predict what this code might output? You think it'll print our number is 6? Any other?
Wait, yeah, just our number.
Okay, so we've got 2 votes for our number is 6. Do you have any suggestions? Our number is 6. Okay. Any other suggestions online, either from Lena or from Armani's?
No idea.
Okay. Well, this is a good time to mention, don't just agree with people because it's a popular answer, because all of you are wrong. And let's see if you can figure out why. So it's actually going to print our number is 6 and our number is not 5. Can anybody tell me why?
Because else it will print if the number like yeah, else it won't print if the number because the second one is not
The second if?
because like else will print if the second if is not printing.
Right. That's actually exactly the correct answer. So the else statement is only predicated on the immediately prior if statement. It's not predicated on this one. So if the number were 5, it would run this section. Otherwise, it will run this section. This if statement up here is unrelated. Typically, and this is just a me thing, this is not, widely done, but I usually like to put a break between unchained if and else statements. It just helps me visually see that this section and this section are completely unrelated. Now, we can make these related by using else if. Now, your original answers would have been correct, right? It will check to be, if our number is 6, if this doesn't run, it will check this and try to run that. And if that doesn't run, it will do this and run this one. Now we can do else if as many times as we want, right? We can also say else if num equals 7, right? We say our number is 7, yay, right? And likewise, this will also only run one of these statements. So if it's 6, it'll run our number is 6. If it's 7, it'll run, I can't type, sorry, 7. It will run our number is 7. And if it's anything else, it will run our number is not 5. And that's just because of the way I've written this here. Any questions on conditionals? Because this is really all there is. No? Okay. So something else we can do is we can put conditionals inside of conditionals, right? So for example, we can say, if num is greater than or equal to 10, right? We could say our number has at least 2 digits, right? And then we can also say, we can actually just do else our number has only one digit. And then in here, we can say if num is greater than or equal to, greater than or equal to 100. Line. Our number has at least 3 digits. Else our number has exactly 2 digits. Alrighty, so can anybody tell me what the problem with this code is? So this will compile and this will run. Worth noting, right? If I run this, it'll say that our number has at least 2 digits and our number has exactly 2 digits, right? Which is true. But can anybody tell me what bug there might be? Every once in a while, I'm just going to ask these kinds of questions just to get you thinking about edge cases. Will this work for all values of num? Yes or no? No. What's the value it won't work for?
9.
None?
No, 9. 9.
9?
Anything below 10.
Anything below 10. Well, it does say that our number has only 1 digit.
Oh.
So that's fine. Anything
Wait, I have a
else?
question. What if it's a
Yes.
negative number?
Haha, nice.
Thank
Yes,
you.
you are exactly correct. So if we have negative 50, for example, right? What is our output going to be?
Error?
Right, it's going to be our number only has 1 digit. Exactly. So remember that the computer cannot read your mind. It can only do exactly what you tell it, right? So it's not actually checking how many digits are in the number. It's checking if our number is greater than or equal to 10. Negative 50 is not greater than or equal to 10, so it's going to skip this entire if statement and instead run this else statement, which is not true, right? So one thing we can do here I think this is how you do it. Gosh, it's been a little while. Yep. Okay. So, so there's a fancy little package in Java that's automatically imported. You don't need to worry about it right now. You don't, but it's called math with a capital M, and it has a handful of functions in here like square root and abs. Abs being short for absolute value, not your muscles. But yeah, so what the absolute value does is it just lops off a negative if there is a negative. So now this will work with any input, any integer input. This will work just fine with, although 0 could hypothetically have additional digits. But yeah, any questions on anything so far? No? Okay. Then let's move on. So I'm going to briefly go over for loops once again, just because I did kind of rush through them last time. So there were while loops, right, which is pretty straightforward. Right, so we can have a Boolean condition that's true, right? And while that condition is true, we're going to do a thing. Right? If I hit run on this program, what's going to happen? Nothing. But more than just nothing, because it's going to do nothing forever. It's going to continue going through this empty loop, doing nothing forever, because this condition is always going to be true. And you'll notice that the program does not end, right? So a lot of times, if you ever notice your computer freezes, it can be due to something like this. It's called an infinite loop, where it's just trying to do something, but there's just nothing for it to do. Okay. So what we can do here is we probably want to have some kind of conditional. When do we want to actually break, right? So we might have, you know, some counter out here, right? Like this, and then we could say, you know, every time we loop, we're going to increase our counter by 1, right? Okay. And then at a certain point, we want to exit this loop, right? Now, I could do something like this. Instead of while condition, we could do while counter is less than 10, right? And then we will actually only run the loop 10 times, and then we do exit, and the program terminates, right? And just for clarity's sake, I will print out the value of counter just so we can see what's going on here. So you'll see that it does do the loop very, very quickly, right? And we do print from 0 to 9. Now, the other thing too is we might not know exactly when we want to, you know, exit. So in those in those cases, or we might have a condition that's a little bit more complicated, right? We could say while our counter is less than 1,000. Right? We know that we only want to loop 1,000 times, but we might want to exit a little bit earlier, right? So we might want to exit if counter is ever divisible by exactly 45, right? So we can say if counter divided by, oh, sorry. So actually, yeah, you know what? I skipped a step that I forgot to do. We're going to put a pause on this for a second. And I'm going to talk about a couple other Boolean signs. So we previously had, you know, 5 is less than 3, right? And we had greater than. Sorry, we had, what did I type? Okay, we had greater than, and we had equals. There's another operator that is not directly a Boolean operator, but is often used in conjunction with Boolean operators. And what that operator is the modulo operator, also referred to as the the percent sign, right? So what this does is this checks the remainder of division. So for example, if I print, oops, that was ugly as hell. If I run this and I say system out print ln, we're going to have 5 mod, sorry, we'll do 50 mod 3. No, mod, let's do 7, because that's a fun one. Dakota, what is this going to print?
It's
That's 50 mod 7. So what's the remainder of 50 divided by 7?
7.11. So 0.1.
No, so the remainder is after doing as many integer divisions as you can, what is left over? So in our case, 7 fits into 50 7 times, equaling 49, with a remainder of 1.
Yes.
So if we run this, and I comment out the rest of this code actually, so it does not run, this should print 1, right? And it does. Now, if I had 52, that will print 3, right? Because it will, again, fit in only 7 times. And with a remainder of 3. Oops, keep typing in the wrong spot. So this is often used to check a number's divisibility, right? Because if we have this, we can then check if this division is equal to 0, right? So is 50 divisible by 7? No, right? Is, let's do, is that divisible by 9? The answer is yes. Right? There's a little trick with division of, for those of you who don't know, there's a little trick with division of 9. Any number where digits total to a multiple of 9 is divisible by 9. So 27 totals to 9, right? 117 totals to 9, thus also divisible by 9. But yeah. Anyways, so we often use this in a lot of different cases. So, for example, I'm going to uncomment this while loop. If we wanted to print out, our multiples of 45, right, that are below here, we can say if, or that are below 1,000, we can say if counter mod 45 is equal to 0, right? Then we print counter is a multiple of 45. Oh. Oh, geez. Okay. So this is part of the problem. Computers are fast. But you can see that every 45 numbers we're getting such and such is a multiple of 45. So for example, 585 is apparently a multiple of 45. The more you know it, the more you know, I guess, right? Now, can anybody tell me what is inefficient about this?
Scroll.
Okay, not the scrolling, but thank you.
It's just not practical.
Right. Is there a faster way to find multiples of 45 that are less than 1,000? How might we change this code to find multiples of 45?
You can a while.
Well, if we remove the while loop, counter is going to be set equal to 0. Then counter will print 0. Then counter will be set equal to 1. And then we will check if 1 is divisible by 45, which it's not. And then the program will end. You want to use a for loop. We could do that. But anything you can do with the for loop, you can also do with a while loop, and vice versa, which we'll talk about in a minute. But it's go.
Can we just remove the system out printing after a while? So now it'll just
Like this. Sorry.
Just remove it.
Like remove.
As in like remove that entire thing.
Like that?
Yeah, because it's printing out everything that's when counter after 1,000.
Yeah, so this is cool, and this definitely makes it easier to see without having to scroll, but is there a more efficient way we can compute this? Because this is still checking every number between 0 and 1,000. Like, what if I wanted to go to 1,000,000 or 1,000,000,000? Is there a faster way to do that? Because this could actually, at a certain point, it's going to start taking a little bit. You can see that although my computer is going pretty darn fast, it's, we're still in the tens of millions. Oh, hundreds of millions. It's gonna be a while before we hit 1 billion, right?
Wait, what's your question?
How do we make this faster? Why is this code running slowly? What is this code doing? That's a great idea. I think that will reduce our number of calculations by 45 times. So previously, we were checking every single value between counter and our number, and we only got up to, what is that? Oh, actually, we didn't even get up to hundreds of millions. We only got up to about 54 million, right? So now, by just changing this to, instead of incrementing by 1, incrementing by 45, we're probably going to get there a lot faster, right? Okay, actually not that much faster, but there's a reason for this. And this is a fun reason. Okay, it looks like it is a little bit faster, but there's actually a bottleneck in this code, and it's actually not what you'd expect. The bottleneck is printing. So printing is slow. And when you're trying to print a lot like this really fast, it is usually the bottleneck here. So there are other ways we can do this though, right? If we were, for example, to have a string, right? And set that equal to the empty string, okay? What we can do is instead of printing every time we find a multiple of 45. We can take our output and we can set it equal to our output plus, and I'm going to put this in parentheses just for clarity's sake, but it does not need to be in parentheses. Counter is a multiple of 45, right? And this would be cool. Let's test this on a smaller number, right? So let's test this on 1,000. And can anybody tell me what this is going to print out? Oh, actually, it's not going to print out anything. Can anybody tell me what this is going to print out? Looking at this side of the room. Your name is Alfin?
Yeah.
Alfin, what do you think this is going to print out? It's okay if you can't figure it out, but let's step through it, right? What do we do on line 4? We create a Boolean called condition and set the value equal to true, right? Now, it turns out we don't use condition anywhere else in this code, so we can largely ignore that line, but right?
Yeah.
Then what do we do on line 8? We create a string called output and set its value equal to the empty string, right?
Yeah.
So it's basically a string containing nothing,
Yeah.
right? But it's still a string. Then what do we do on line 10? You can do this one. So what is the type here?
Image.
It's an int.
Yeah.
And what's it called?
Counter.
And what's it equal to?
0.
Right. So we're declaring an int called counter and initializing it to 0.
Okay.
Right? And on 11, we're going to check if counter is less than 1,000, right?
Yeah.
And this is commented out, so that's not going to do anything. So then what do we do?
So the counter plus 45.
So what does that actually do? Counter was previously what?
So it's 45.
Right. Then what do we do?
45 is divisible by 45.
Yeah, if the number is divisible, which in our case is 45, is divisible by 45, then we take output, which is what?
0.
No.
Oh, so that's right. Yeah.
Yep.
Okay.
So it's going to be equal to the empty string
Yeah.
plus counter. What is counter?
0. Well,
Or is
Well, what we just talked about, what was it equal to? It was 0, and then I got updated to what?
45.
Right, so 45 space is a multiple of 45.
Yeah.
So output is now going to be equal to nothing plus 45 is a multiple of 45. So output is going to be equal to 45 is a multiple of 45, right?
900. Sorry.
Getting ahead of us. So then we're going to go back up to line 11 because we hit the end of our while loop, and we're going to go up and check line 11. Is 45 less than 1,000?
Yes.
Okay, so what do we do now?
You add 45.
Right, to 45. So it's
Yeah.
now to counter. So counter is now what?
90.
Right. Is 90 mod 45 equal to 0? Yes.
So it's super. Okay.
So then our output is going to be equal to our output, which is what? What is our output?
The
It's a string, and it was currently equal to 45 as a multiple of 45,
Yeah.
right? So it's now going to be equal to that plus
90.
90 is a multiple of 45,
Yeah.
right? So if we run this, we're going to get a bunch of garbage. Why do we get a bunch of garbage? Well, it's because we don't have new lines here. So back when we were printing on every line, this ln here automatically adds a new line afterwards. But because we're not printing, we're now just adding it to a string. We need to do that ourselves. The way that we do that is we use what's called a special character, an escape character. In programming, this is the backslash. So we can put a backslash and then a certain letter after that, and that'll be a special character. In our case, this is a new line. Backslash n is a new line. There's a couple other ones that are worth checking, or that are worth knowing. Okay, so we're gonna do this. Escape characters. 1 second, Lena, I do see it. We have \n, which is our new line. We have \t, which is tab. We have backslash. Those are the only ones I really ever use. I think \b is backspace. I'm actually not sure about that. Yeah, so there is \r\n, which is not really used in Java, but is used in other languages because there is a difference in operating systems between a new line character and a carriage return character, which was it's complicated. You don't need to worry about that right now. If you ever do need to worry about that, it'll tell you. But sometimes you will see \r\n. We're not going to get into that. For now, these are the two you need to know. Okay, yes. Lena, what was your question?
Oh, I'm good. You answered it.
What was it? I'm curious.
I asked what came after backslash if you had like definition of what each letter meant, and you literally just
Yeah.
answered it. So
Yeah, and there are resources you can find on Google, right?
is this all across like no matter what else you use, like, or is it only in Java?
So it's actually a really good question. They are typically the same across languages.
Okay.
Right?
It's
They're
like the thing
typically
that
the
we
same
were talking
across
about last
languages.
course. It's like the thing we were talking about
Technically,
last course. No?
Say that one more time.
Is it exactly like what we talked about last course? I forgot what it's called, but it's like those like things like the original words like that you can't use in your code.
Oh no, those are what is it called, Himanshu?
Primitives.
Not just
Keywords.
primitives, reserve words.
Yes.
Yeah, that's
Got it.
separate. So these are just special characters that, because like you can't put an actual new line in a string, right? If I actually try to just hit the enter key, I now have two different lines. I have a string that doesn't terminate on this line and another string that starts on this line and doesn't terminate, right?
Are these like
There's no-
shortcuts? Are these like shortcuts like how we have like on keyboards, like not through keyboards, but like different systems? You know how like you go from Windows to Apple? It's also the same thing. It's like Control C.
So Java, what's nice about Java is that it is a cross-platform implementation. So basically, it will handle any differences in operating systems. That is true for a lot of what we refer to as higher level languages, like Java or Python. It is not true for lower level languages like C or C++, which means that yes, sometimes in lower level languages, we will need to use slightly different characters to get different results.
Got it. So in
On
C++,
different operating systems.
it wouldn't be like \n for a new line. It would be something
Well,
different or no?
it's still \n for new line actually, but sometimes we need to do slightly different outputs for different operating systems. So you'll often see code that looks like basically like if OS is equal to like Windows or something, right? I'm oversimplifying it quite a bit, but you'll actually see code like that.
Okay.
Windows often runs slightly differently than Mac.
Yeah.
Although they have actually made a lot of effort in the last decade or so to unify and start running the same way because it makes it a lot easier to program.
Got it. Okay. Thank you.
Yeah. So with this \, you'll notice that we're actually, because we're only printing one time, we're actually able to print a lot faster than if we had different lines. So even if we bump this back up to, that's 1 million. And then if we try to get to our 100 million.
Also, just a sec. Since we have the counter less than 1,000, it's still in 1,035 because we're incrementing afterwards.
Oh yeah, you're right.
Yeah.
Yep. That's a great thing to know. So yeah, even though we were saying while our counter is less than 1,000, it's still printed 1,035 as a multiple of 45 because it actually checked back when counter was 990, then it added 45 to it, right? And then printed.
We must start from -45 because technically.
Yes, if we wanted to do that. Yep.
Multiple of 45.
Yep, you're right. Or we could just put this there. Not there. There. Anyways, you had a question?
No.
Okay. But yeah, so if I run this, you'll notice we're now able to get to So it's currently doing the actual math to get up to 100 million. And it should be quite a bit faster than our other system, although it is still going to take a little bit, especially because this modulo operator takes a minute as we get up there. Now, do I have any other suggestions on how we could make this faster? Because it looks like it's still taking a good bit of time.
Like some bitwise stuff.
Nope, not. We don't need to do some bitwise stuff. I gave you a hint. Is that conditional ever going to be false? The way that we've coded it?
No.
No. So we can actually remove this.
Just remove that, yeah.
We can just remove this entirely. Right? Because we're no longer checking every single number. We're only checking after we've added 45, right? So we can check and we can hit run. And let's see if this is fast enough that it'll actually finish in time. It might not. We actually might have enough characters that we're overloading our string. I'm not 100% sure. It's hard to tell without outputting. So what we might be able to do is we can say, you know, if our counter mod, and then we're going to do 45 times, let's say 100, right? So actually, I could just do that in my head. Is equal to 0, right? Then we'll just system dot out dot println preparing currently at, then we can do, and I might even do 45,000 here. There we go. And let's see if that is any faster. And you're taking too long. Run. Oh, right. Gotta have your closing conditional. Okay, so it's definitely faster, but we're noticing that it's getting slower every time. It's actually getting slow pretty fast. You guys are not going to know why. Himanshu, do you know why?
Oh, why it's getting slower?
Yeah. I'm kind of curious if you know.
Because like the bigger number,
I don't know,
it takes about a
thing.
or one thing.
So, sorry, say that again?
I was just thinking, is it just adding on to the string? So the string is just getting longer
It
and longer.
is. The string is getting longer and longer and longer, and the way that it's adding on to the string actually makes it substantially more expensive the longer the string is. So yes, that is the answer. There are faster ways of doing this, but that's not really important for what we're trying to do. So yeah. Anyways, this was not, the purpose of this was not actually to write it as fast as possible. It was just to go through the process. What?
I said I should be hired as software
You
engineer
should.
at this point.
You should. By the end of this course, hopefully we all get hired as software engineers. Or at least hireable as software engineers.
Also, I'm finding parking, so I'll be at class soon.
Okay, sounds good. Yeah, just knock on the window when you get here. Or caca from outside the window as well. Okay. Yeah, so any additional questions on while loops? No. Okay. So we can now do for loops. I like for loops more. I very rarely use while loops. So for loops have 3 different sections, right? We have our do at beginning. Oops. We have our condition, which is exactly the same as a while loop, by the way. This middle one is exactly the same as a while loop. And our do every loop. And then we have do things. Right? And you'll notice this is basically just a while loop, but with extra steps. And in fact, if you have a for loop that has nothing in the first section, only has something here, and nothing in the second or in the third section, you'll actually basically just have a while loop, right? And we can just have, counter plus equals 1. This, by the way, is shorthand for counter equals counter plus 1, which I did mention last class, but I just want to review it here. Oh, yeah, right, because this is an infinite loop. Oh, what do you want? Okay, yeah, because you're not going to do that either. Okay. 1. What do you do with that? Okay. Oh, right, I didn't print. Okay. So this will just print 0 to 9, exactly the same way our while loop did, right? So why do we use a for loop? Well, the main reason that we use a for loop is if we want to have these statements built in for us. So one of the main uses that you'll see for a for loop is iteration. So you can have, our int I equals 0. And very often you're going to see this, where I is our iterator variable. So what this is basically saying is at the beginning of the loop, create an int, declare an int called I and set it to 0. While I is less than 10, do things. At the end of every loop, increment I. Okay, does everyone see how I got to this explanation from this code here? Right, so if we run this, you'll notice it also just prints 0 to 9, right? And this can be pretty neat. We can do some real fun things with this. One of the things I like to do here is we can say, or we can have our int number equals, let's say 100, right? All right, now we're going to do a little in-class project. I want to write code that will find us all of the factors of a given number and then tell us if they are prime, if the number is prime. So we're going to work on this together. Can anybody tell me where to start? I'll give you a hint that this is the loop that we can use.
If it's not, oh, wow.
So I say that one more time, Lena?
I think that if we can run a code or a formula, like if it's not divisible in 9, 8, 7, 6, 5, 4, 3, 2, 1.
Right. So that's basically what we're trying to do is we're going to be trying to see if our number is divisible by all of these numbers. And if it is, we need to print that that's a factor. Right. So we're trying to find all the factors of 100. All right. Oh, I think she's here. I hear the cacaw. Emmy, can you grab her? Yeah, but she still can't get in. Thank you, Emmy. So in our case, we have 1 by 100, right? We have 2 by 50, right? We have 4 by 25, and that's actually it. Oh no, that's not. We have 5 by 20. Hi, Lena. Welcome, welcome.
Sorry, it's so late.
Here, you can.
No, I'll sit there because I'm gonna have to. Charger. Yeah.
Okay. And then E, you can sit over here if you'd like.
I need to distract the code.
Oh, okay.
And
Sure.
you'll get started.
All right. Are there any other factors in 100? I don't think so. I am not very good at math.
Wait, what are we talking?
Sorry,
What are we talking?
What?
What are we talking?
The factors of
Factors of 100.
Wait, I'm
Two.
confused. What is your question?
We're trying to find all the factors of 100.
2, 5, prime, not prime, anything.
Me.
Oh,
right? So this is,
10 times 10, yeah, that's it.
yeah. Oh yeah, 10. Thank you.
Yeah.
Right?
And then 20. Oh, we did that, sorry.
Yep. And then we would also want to get the reverse, right? So we would also want to find 20 by 5 and 25 by 4 and 50 by 2.
You already did that. You did 2 times 50.
Yeah, we also had,
But
yeah,
it's
so we're trying to do the reverse as well. And then 100 by 1. Well, I'm just saying, this is the example output for what I want to have in for this particular project.
Alright.
Okay, so how can we come up with code that will actually print this automatically? Did you have a suggestion? I like it. Share it.
Oh, I don't know. Okay, for pi equals, I guess 0,
Sure.
and then what's the or equal to the number,
Mhm.
and then plus, and then if number I equal to 0, then you can I
If number mod I equals 0, system dot out dot print line I. Like this? Okay, so this is going to have a couple of things, right? One of the main issues that we have is we're going to get a divide by 0, right? So modulating by 0 doesn't work for the same reason that dividing doesn't work, right? So how can we fix this?
Oh, the first number for I could be 1.
Right. So if we start I at 1, that'll fix the divide by 0, right? Now, the other thing is that we're not actually printing out their pairs. So we have 1, but we don't have 1 by 100. So how can we edit our code? I respect you. Let's try and get someone else to answer. Alvin, do you have any suggestions?
What's the question?
So right now we're just printing 1, 2, 4, 5, 10, etc. What we want is 1 by 100, 2 by 50, 4 by 25.
Can you add like for that print up the output, we just like add a what is it like the apostrophes, and then you write it in.
So what do you want? You want me to do like that?
But then you gotta add like a.
So these apostrophes will turn this into a character. So this is just going to print the literal character I, right?
No, but like you add that to like the output from before, then you add.
I'm not sure I understand what you're
No,
trying to do.
never mind.
It's okay. It's okay. It's
Yeah,
okay.
never mind.
Do you have any thoughts?
So like, you want to actually print out like 1 times 100.
Yes, I want to literally print 1 times 100 here. It's okay if the spacing is more like this. That's fine.
They should be printing. I know this is gonna sound crazy.
What?
Just think about like having the answer times the reverse of the answer.
So what does that mean?
Number times.
Sure. So what do I?
But you cannot be there. I'm too hard to sure. I'd be so thorough.
Okay, so we have this. We can at least get the x in, right? By doing something like this.
Yeah.
Then how do we get the other side of it? What do you mean the reverse? By
Like how the inverse.
oh, you want me to print it backwards? So that's actually interesting to think about. Unfortunately, we can't really go backwards in programming,
Oh.
right? So because this is actually running the code step by step, it can't really go. You can't unrun code. This is actually a whole thing that C# has, I think, the only debugger in the world as that I'm aware of that can actually step backwards in debugging, which is kind of
In
crazy.
debugging, not printing.
Yeah. But debugging, it can step backwards, which is kind of cool.
So what did you do? Like you add like plus.
All right, so yeah. So to concatenate combined strings, we do plus, yeah. So we have on the left side one of our factors,
Yeah.
right? We have I. How do we get the other factor?
So you add plus and then like number divided by I.
Beautiful. Nice. Good job, everybody. So we can actually
Wouldn't it
change
be slightly better to have like an int something is equal to number divided by I and then putting in print.
You lost me there.
int number equals.
Like
Oh,
wouldn't that be
oh, you clever little shit. I'm sorry, clever little person. So you're saying that once we find 2 to try and divide 500 by 2, or to is that
no,
what
no, just like instead of doing the whole division just randomly floating in the system print line.
Yeah.
Wouldn't it be better like code etiquette to like declare integer and say that this is the
you can? Yeah, so basically what he's saying is, why don't we do something like in product? I don't do math. Like this,
yeah.
and then products. So we certainly could. For me, the reason I didn't do that is because we're not going to use product anywhere else. And if we're only
It's
using
taking
it,
space, yeah.
if we're only using it in one spot, I like to just put it in line. But you could certainly do this and have it in its own variable as well. There's nothing wrong with that.
I guess you like to label stuff.
Yeah.
Not a
Yeah. I mean, yeah, it is certainly, this
It was
is
like
probably,
unexpected results or something.
yeah, I mean, this certainly would, they run identically.
But
This,
whenever we do division, like usually you want to make sure like
yeah. So fortunately in our case, because we're working with entirely integers and we're
Yeah.
only dividing when we know that something is purely evenly divisible,
yeah,
we're okay.
so it's fine. Yeah.
Yeah, so it is fine. But you're right that that does help alleviate some possible type obscurity. That's true. But yeah, the code is identical in either case. Any other questions about this? So you can see that this code actually runs pretty quickly on even up to 1,000, right? Which is kind of neat. Let's test 1,000,000. So that was very fast, right? Let's test 1,000,000,000. There you go. Look at that. So it just it found every factor of 1,000,000,000 in, what was that, maybe 1 to 2 seconds? Right? So pretty cool. Good job. And you'll notice that the reason it was able to, even though it was still looping 1,000,000,000 times, like our last one, it was able to do it a lot faster now because it wasn't printing or doing string concatenation every single loop or every 45th loop, right? Because you'll notice that for a large portion of these, there just is no other section here, right? I think that's kind of neat. Anyways, okay, so any questions on for loops, while loops, or anything else? Well, I've got you all here. Anything else? Anything else that we've covered so far? Armani, is anything from your end?
We can do an example of a reverse for loop, like where minus minus over.
Sure. Yeah. Well, we can do that, and then I'm gonna give him a mini project just for the second half of class, and then and then while they have the mini project, I will pull up the files for the actual project. Which, by the way, I found all my old projects. Let's go. Anyways, okay. So we can also loop backwards, right? Or air quotes backwards. So sometimes, you notice in this case, we started with 1 and worked our way up, but we can also start with the high number and work our way down, right? So we can have int I equals number, right? While I is greater than 0. And then we can I minus minus. So Lena, I think this may have been what you were kind of getting at. where we go backwards down, right? So we can say if number mod I space 0, oops, 0, system dot out dot print line I.
Why don't you do a double equal sign?
So single equals is assigning. It doesn't actually, it's not a comparison. Double equals is a comparison. It's saying, is the left equal to the right? Does it hold the same value? The single equals is assignment. It's saying update the value of the left to just be the value of the right. And a lot of earlier programming languages, they actually used like an arrow sign to be, or instead of equals.
Equals
So-
arrow.
No, so it would be like it would look something like you know, int a, something like that. The problem is we needed this character to be used for comparison. So this is just what we settled on. Yeah. Okay, Himanshu, any good ideas for a little mini project that I can have them do while I pull up a big project? I should have thought of this in advance, but I didn't.
Binary search.
That might be a little bit too advanced this early on.
Oh.
I like that though, because that does technically work with everything we've done.
Yeah.
I think that might just be. You know what? I'm gonna make that their take-home project. But let's give them a simpler one for class. I like that actually.
You did give something challenging, which I forget. Little mathematics.
Like think something on the lines of
Oh, the prime thing.
think something on the lines. Oh yeah, okay,
Yeah.
that's a great one. All right,
Yeah.
all right, y'all. Write me a program that will find, what was it?
Which checks whether the factor is, or like
Let's find
a palindrome.
Palindrome. We haven't done enough with Carat. Hold on. Let's do.
FizzBuzz.
Yeah, so lame. Everybody does FizzBuzz. I kind of want to make him do prime factors.
Yeah.
I do. I think that's actually what I'm
Print
gonna
all
do.
the prime factors in a string, but nothing else has to be printed.
Yeah. I think that's what I'm gonna do. I'm gonna make you guys find the prime factors of. Yeah, I like that because that's good because first you can find prime numbers in an outer loop, and then you can actually do the factorization in an inner loop. I like that. Okay. So your goal now is to find prime factors.
I don't know what is prime.
Yeah. So you're going to be finding all the prime factors of a number. So for those of you who don't know what prime factors are, okay. So I'm going to start with 100.
That's the challenge.
So basically, prime factors are all of the prime numbers that can be multiplied together to get a number. Every number can be made up by multiplying primes, right? Because it either is a prime itself or it is a multiple of some number of primes.
Like
So in our case, 100, right, is going to be 2 times 2 times 5 times 5,
Yeah.
right?
So for example.
So in our case, I would then want you to just print 2,
Wait.
2,
Sorry, factors.
2,
What are
5,
the prime ones? Like the ones that are prime.
5, right?
No, but that's not a factor. 70 and 70 is not a factor.
I'm one. Oh,
Yeah. So Lena, for example, 100 can be broken up into 2 times 2 times 5 times 5, right? Those are the prime factors of 100, right?
Oh, so we're doing a prime factorization of 100.
Yes.
Okay.
Yeah. So 51, for example, is 17 times 3,
yeah.
right? So that's what we're trying to do is we're trying to print out all the prime factors that can be multiplied together to create our number.
So basically, every single number that exists can be can be shown as a product of prime numbers.
Yeah.
It's impossible to not do that. And
Yeah, it either is prime itself and thus has no prime number
Yeah.
or prime factors.
This is why UMass requires math for.
Probably.
Yeah.
But are there any questions on the mini project?
I'm not doing that.
Can you repeat?
Yeah, so you're take the
What do
number,
you think is?
right, like this,
the
and
biggest
then
roadblock?
write out the prime factors of the number. Print out the prime.
No, we can do it. We can fix
No,
it.
we printed out the factors, not prime factors. So in our case, if we had 2 times
What
50,
are prime numbers?
50 itself
What
can
are
be broken
prime
up into 2 times 25.
No, what are prime
25 can be broken up into 5 times 5. Thus, prime factors are 2, 2, 5, 5.
numbers?
All of those numbers are prime. All of the
Like
printed numbers.
this is like as easy
Yes,
as anything
yes.
would ever get.
Oh, sorry, you didn't know that definition. Yeah,
Like-
prime numbers, I should clarify, prime numbers can only be divided by themselves in 1. So prime numbers are like 2, 3, 5,
Okay.
7, 13,
Just think of
11, 13. I'm bad. I don't know the primes. 17, 19,
Except for
23. But yeah. Good luck.
I could, but right now we need to do the prime factor. So what is a prime number? Just tell me that. What's a prime number? You don't have to make a project. Great. Okay. What's the prime factorization of 24?
Again.
Countless.
Yeah, you should. I think so.
How would you express 24 as a product of just prime numbers? Okay, what's the smallest prime number?
Okay, how do you start things? Public.
What's the smallest?
No.
What is one
You
prime number?
still have the
No.
code for when we find the prime factor
Oh,
of 100.
So one is not a prime number because to be a prime number you have to be divisible by 1 and yourself. Meanwhile, 1 is a special number, so it does not count, right?
So yeah, it's
1 is
two.
0. So 2 is a prime. 3
2 is a prime.
Is 4 prime?
Yeah.
2.
It's 4 prime?
3 is
No.
prime.
It's not. a
No.
prime. Oh, it is. Fuck. What about 6?
3 is the only multiple of 3 that's prime. 2 is the only
Basically,
multiple
the
of
way
2
the
that's
prime
prime.
factorization is you start checking with 2. It's 24 divisible by 2.
Yes.
So, okay. So 2 is one of the prime factors. Well, the first thing is prime factorization. Then once you divide 24 by 2, you
Finding
take the
all
2
prime
away.
factors of the number.
That makes, what remains after that? What do you multiply by 2 to get the 24? Yeah, so now if you look at 12, is it divisible by 2? There's one more 2 there.
And then
What remains? 6.
It's easy to just print out all of them
All the,
based on the prime. Print out only the prime numbers in the factor.
main.
yes.
Okay.
No, you have to express it just with prime numbers. basically.
Yeah.
Yeah, so there's 2. Once you get to 6, is there another 2 in there?
Cool, this project's too hard. Is this part of the midterm? I'll put my brain cells together if this is part of the midterm. But if this is just one of the homeworks, I can fail.
This is
That's why we're going like slowly.
and then
Because we're taking our time. There's no like time limit on this, right? So we need to understand this. Well, you don't have to do the project. I'm just saying like, you need to understand what we're doing in the first place. That's what I'm saying. Like once you get to 6, so there's 2 and 2. Once you get to 6, is there another 2? What?
What I'm thinking about right now is food. Literally Popeyes. Sounds so good. Except,
You know what?
what's
Once
her name said it
if
was
you're gonna
good.
order delivery from Popeyes, you know what algorithm they use on the app?
Stop.
So true. Okay, well,
It's too much.
so Lena,
What?
whether or not regarding the in-class exercise, you don't have to do them, but it is good practice. And if you want to actually learn this, I would highly recommend you do follow along or do them in your own time. If you don't really care, that's fine. But
It is really important.
yeah, it's good practice. It's good to have practice.
Yeah, I believe that. Yeah, this is what
No, that was unrelated. You starting
I
with
appreciate all this brief.
I know. Okay.
Which could be sometimes more difficult than
Yeah.
this.
No.
No, 100%.
So you can do this week. If you do that, you can do this.
I spent all day today doing it. Good. Still doing it. I know I have to make up work hours right now. So
Go.
if you want to work, then just go.
Sure. So what is a
Good
prime
luck.
number?
All right, and feel free to ask
We can make that
questions.
one time.
I'm happy to answer them.
Oh, do you want to learn something new? Yeah, so you want to learn something new?
If you guys want to go do your own thing, go for it.
No, I just want to. Thanks, Dakota.
Feel free to
No,
go.
I was like, what is a prime number? She's like, I already know that. So I was like, okay. So that means you want to learn something new.
Yeah.
No.
Like prime factorization.
I'm good. No, just walk me through it. I'm good. My brain
So what are you
is like-
thinking?
I'm very overwhelmed right now.
Okay.
That was too much, yeah. You know what's not?
Because like right
What's
now,
what?
we're just
You know what's
looking
not?
for prime factors.
What?
Lower than.
Is there a Popeyes?
So we're not
How far
prime
is it?
numbers that are lower than 100. It's specifically the prime factors that make up. Right.
You know what? If you solve this, I'm gonna go to Popeyes and bring it to you. But you have to solve it for that.
I'm gonna have one of mine to go buy myself.
But no, he's saying he's saying he'll go pick it up for you so you can sit.
I'll just Uber.
But that would be
Uber's gonna use the algorithm.
yeah,
Yeah,
that's true.
Well, it is what it is.
2 blocks away.
Okay. So the way that I like to code is to do it myself on a simple example and then see what did I actually do, right? So if I ask you, Charity, to come up with the prime factors of, I'm going to say 40, what do you do?
I look at I find all the multiples of 40,
Okay.
and then I determine which ones in there are prime.
The factors of 40, you mean? Okay.
Yeah.
So like looking at 4 and 10, you'd say no, because neither of those are prime.
Yeah.
And then 2 and okay, but what about an example like, for example, 24, where we have actually 2 that are prime. We have 2 and 3, as well as 4 and 6. And 8
There's I don't know what
Is this
and 12.
private? What is?
E public.
The medium of them?
Well, 8 can be broken down, right?
They can.
Any
Which
question?
is great. So you're going to continue to break it down until it can't anymore.
There is.
So I think but like, how do you know whether to start with 2 and 2 or 3, right? Because 2 pairs with 12. 3 pairs with.
I'm willing to let you start thinking about that.
Okay. That's okay. So what I recommend doing
What's
The way that I like to do it
thing
in my
you're
head
willing to get from
is, and maybe you guys might want to listen along to this. The way that I do it in my head is I start by finding the smallest prime number that the number is divisible by in the first place. So, for example, if I'm looking at, let's just take one that I've never done before, like 117, right? 117 is not divisible by 2. Is it divisible by 3?
Great example, by the way.
Yeah, it is actually divisible by
It
3.
is divisible.
It's divisible by
Yeah.
3 and
Well, there's one more three in there, actually.
hold on, wait.
Not
So
that- yeah,
117 divided by 3 is, okay, 39, right? So now I know that it's 3 and 39. Now 39, I know that 39 is not going to be divisible by 2, right? Because if 39 were divisible by 2, so would 117,
Hmm.
right? So we can still start with 3. Is 39 divisible by 2 or by 3?
Three.
Yes, it is. So we know that it is going to be 3 times 3 times 13. Okay. So then is 13 divisible by 3? No, it's not. What's the next prime number? Is 4 prime? 4 is not prime. Is 5 prime? 5 is prime. Is 13 divisible by 5? No, it's not. 6 is 6 prime? No, 6 not prime. Is 7 prime? 7 is prime. Is 13 divisible by 7? No. Right? Is 8 prime? No. Is 9 prime? No. Is 10 prime? No. Is 11 prime? Yes. Is 13 divisible by 11? No. Is 12 prime? No. Is 13 prime? Yes, but it also
We
is
only
the
have
last
to do it in
number.
half of 13, basically.
Actually, you only need to go up to square root of 13,
Yeah.
but yeah. So that's how I just found this. So if you'll notice, I had a loop that was just going through and finding the smallest prime numbers possible up to, a certain number. And then once I had that prime, I was checking, for each prime, I was checking to see if our number was divisible by that. If it was, I was dividing the number by that and printing it out. Right? Let me get your projects in the meantime. Although I do like the idea of binary search. I might make you guys do binary search instead.
Or like some quirky example of binary search.
Yeah. Binary search, but all the even numbers have guns and will kill you. Okay, this would be GPA calculator. That's not very useful. Or receipt generator? Really?
If you want to look up small quirky projects, I forgot the website in Java. Some shit it's called.
Yes, you can use VS Code, but I will not offer help for using VS Code. I do recommend you use JGrasp for now, though. Just because JGrasp is a much dumber IDE, it is objectively worse than VS Code, and it makes you do a little bit more thinking yourself rather than coding for you, which is just good when you're learning.
Coding badge.
Oh, okay. Huh.
But yeah, I mean that might not be like very.
Yeah, I think I'll code up
But it has some very easy ones though.
yeah, I think I'll code up binary search for them later. Yeah, because this requires classes, which we have not done.
Oh wait, this is not that hard though. I think.
Yeah, binary search is not that bad. You can do it. It's just okay. So, given what I said earlier, I'm gonna mock out some rough code here. Okay. So, goal. Find the prime factors of number.
I'm not sure. It's fine. You don't have to get it for me. I mean, I thought you were gonna get like.
What?
No. From Papa. You can like. I'm not like gonna be like a barrier to go to Popeyes.
So here, I'm just gonna.
If you want to go to Popeyes, that's completely.
Well,
I'm not
going to
like.
IKEA. I'm just gonna talk about sportsy thing. Because Bono's
I'm not gonna hungry. No, I'm not gonna hungry.
right.
Yeah.
So we're not at Bono level, but we're at Popeye level.
But Popeye, I can.
Yeah.
That's fine. I'm completely okay. Like this is usually about the time I eat anyway, so it's fine.
Okay, let's see. What kind of sushi are we having?
I'm sorry, what?
Is that an old world?
Oh, never actually read this book.
No.
Oh.
Where did that book come from?
No idea.
I don't know.
Oh, that's cool.
This one,
Yeah.
I was
learned a
at
lot about that.
a shop and I was looking through it actually.
Okay.
It had one of the anime places that like literally is like in Chinatown, I'm sure.
Like you place for oh, I've been to Punjab.
Yeah, like it.
It's like cheap food, but not good. It's fine. I'm absolutely so. Like something can be there.
Oh, maybe get in store from their store. Okay, we're
There's nothing gonna be. I mean, on location based.
it is like it says.
The wonders of
like,
technology cannot be replicated.
like this mad.
Switzerland is gigantic.
Yeah, it's huge.
I mean, you know, we're going to
Honestly,
there's so many.
you will need. See, last time I haven't.
Alvin Graham. Where's Graham from here? Last week.
All right. Does everyone see my pseudocode up on the
Oh.
screen?
Are you interested in this? I'll help you through it.
Well, somebody else, not me. I'm on food. I have bigger problems right now.
Does this pseudocode make sense to people?
That's true.
Does it actually, or are you saying yes so that I'll stop
Yeah, this
asking?
is
Okay. So let's code that. How do we loop through ints less than number?
Drag this. I cannot. We can go.
Oh no, I don't want to go there. I go there all the time though.
Really?
Yeah. Love this place. It's a great place. Alright.
Okay.
I don't know what this was. Damn it.
I recommend throwing the balls out. Because it's like a small little snack that's gonna.
Yeah, but remember what God, her name is. She's right. So I will get this.
Ooh,
She has a fashion designer name, but it's not Versace.
Sony?
Connie was here last time.
What?
Yes.
Oh,
No, but
Armani's.
not
Armani's.
Armani. There we
Yeah.
go.
It's like fashion
It was like fashion designer, but it's not Versace, is what I know. That would have been. But yeah, Armani said that she didn't fuck with Popeyes.
What? I mean,
It tasted weird. Like it doesn't taste the same. It made her feel
So,
unwell. I'm
you go there all the time.
Yeah.
Oh, you don't? Oh, okay. I thought like it was because you like them.
I was like,
I like. I mean, I know there's a sandwich place here that
This
I
is
like,
good.
but
I will warn you. My pseudocode makes your line 7 look deceptively
Or
simple.
you could just go
It's
to a
not that
regular,
simple.
like your Bodega Deli and get. Honestly.
Because how do you know if a number is prime?
Right.
Right. Break this up. How do you know if a number is prime? That's not a rhetorical question. How do you check if a number is prime?
It's not by any other number.
So how do you check? Like if I say is 14 prime?
It's divided by any number up to 14 to see it.
Technically, you can cheat and you can actually do up to the square root of 14. Because if it's not divisible by up to that, it won't be divisible by anything after that. But yeah, so that might be a loop in itself, right? So it's trickier.
I don't like the look on M's face. Makes me really concerned.
Are you doing your project?
We're trying to figure this out.
She's trying to do this one.
Numbers. That's where it gets me.
Well, I thought
I think you
were
could have done a
already-
math 101 or something.
I thought you were already ahead.
What?
I thought you were already ahead.
I haven't done this. I haven't done any projects.
Yeah, I haven't given her any actual
I
projects.
also got stuck on.
I think we
TikTok,
could have
so
done.
just
I think we
like
could have done math 101.
Yeah, maybe. I don't think that's the issue here though. Because I am ass at math.
Yeah, but like, you know what UMass required for this class, by the way? Calc 2 to be.
Really?
Yeah.
They didn't require Calc 2 for.
What?
Oh my god! No, they didn't. They didn't. They
Oh, sorry,
required
not
Calc 1.
Calc 2. My bad. My bad.
Calc 1.
They needed Calc 1. I think.
Yeah, Calc 1. Well, you
No,
needed
you
an
didn't
R2 math. Calc
Yeah.
1 was an R2 math.
Did you need Cal to?
No.
You don't, right?
No.
Sorry?
So there are definitely people who never took Cal.
Yeah. She's not interested in my services.
Yeah, no, unfortunately.
You're asking what is the square root of or how to find a square root?
Like,
Like, what were you saying about it? Why do we care about
Oh,
square
okay.
roots?
Because once you get past the square root, There's
Zero
no way you can
is
find a factor because like the square root is
not technically
number
a number
that
at all.
you multiply twice. You get
So no.
to, like, for example, 13, right? So
That
what-
I'm
the
not going to
square
get
root of
into with
13
you, but no.
is like 3 point something.
Yeah.
Because 3 times 3 is 9.
Because zero
four
is
times four
divisible
16,
by every other
which means
number on the
that
planet.
if it's 3 point something,
Right.
4
Zero is
cannot be a
divisible by
factor of
4 and
13 at
5
all.
and
I mean, it seems
1,000.
apparent, but it's like in the
Okay.
millions
It's
or
also
something,
not a
it would be
number.
easier to find out. For example, 100.
The way my math
Like,
teacher taught it.
10 is the square root of
Doesn't
100.
Yeah.
But there's like, once you get to
Zero
that,
is the
you
lack
cannot
of
find a
a
prime number past it. That would be a prime factor of, yeah.
The way I was trying to do it was to divide 100 by 2 and then just keep looping that.
So yeah,
By the next-
that is a good
which,
idea.
Which it goes, and I don't know, you probably run into some conflict. I don't know which number would that be to divide. Because it's not divisible by 2, it's not like a.
Your thinking was correct, by the way. But there's the reason square root is better because let's say you're finding additive factors. For example, like how many things you have to add to get to 100. So you cannot find anything over 50 because 50 is like the half in the addition sense. Meanwhile, square root is like kind of like the half in the multiplicative sense.
Sorry.
Right. Like you think about it, if just looking at 100 as an example, as soon as you get up to 10, the other side of it is 10, right? 10 times 10 is 100. So if you went over 10, you're just going to find the numbers that you already found, right? If you already found 2 and 50, and 4 and 25 and 5 and 20, right? Once you go past 10, you're going to hit 20 and 5, but you already have that. You don't need that anymore.
Okay.
You already have that because you got it when you hit
Yeah.
5.
Yeah, I got that.
Yeah, that's all it is. So it just lets you cheat a little bit.
So I should be doing this square root.
Oh yeah.
Would not.
I had a kid come to class at
Like,
high
how do you
LSD.
find square
He was in
root?
Himanshu's class actually.
Oh,
There's a
right.
kid I had to. I didn't.
Actually,
No, I didn't tell you about this because obviously you were a student at the time. But one of the kids in your class I had to take the disciplinary action because he kept showing up to class on LSD.
Wait, how do you? But everybody's camera was on.
Because his camera was on every once in a while, and he was like tripping balls. And every once in a while, he would like stay after class for a little bit, and he'd start asking me the weirdest fucking questions.
Wait, who was it?
I can't say.
No, it might be a friend of mine.
It's probably not. But yeah,
And he admitted to-
so I was like, hey, dude, look, like, I don't mind you, whatever you do on your own time is on your own time, but it's starting to disrupt class a little bit. Like, I can't, have this keep repeating. And he's like, sorry, man. I'm just like, I discovered LSD like last month, and I've just been having a blast ever since. And I was just like,
I think I had friends that went to class.
that's
Intro classes are the best because you meet like so many different people. Like there's people from there who are like
yeah.
millionaires right now from
Yeah.
that class, and there's some people who
Yeah. Oh yeah, no, I know a couple of kids from 121 classes I've taught got crypto lucky, became multimillionaires. Yeah.
I also met Max on Monday actually.
Oh, fun.
Because I was in Maths for just one day.
Oh, cool.
And he works in MathWorks now, but the upcoming fall semester he's going to be teaching as a TO the new intro course. And yeah, UMass like salaries have gone up a lot for TO, like 45 or something like that.
So you find the square root of a number,
Only loop until that. Like stop looking afterwards, basically.
and then.
You don't need to worry about that optimization right now. I'll explain it later.
Goes faster to divide by two, and then the ones that you can't, that are
Q?
divisible by 2.
Oh, 2. Yeah, sure. Right.
And-
No, you're right.
And those become square rooted, and then you figure it out.
Wait, why?
Yeah, like for example,
Doesn't it
25 is
matter?
not divisible by 2, but it's not.
What?
25 is divisible, not divisible by 2.
Because
but it's not.
like fusion food is more fun. Like
Right. But it's divisible by 5.
nice.
Yeah. Okay.
Well, so you start with 2 and then 3.
I just think that like it's kind of
Of what?
It's something that you should get there. Also,
Look at what I'm
try
writing
to-
on the board.
Yeah, like you should. if you can put it like usually that's like more fun. Like,
Oh,
yeah.
No, I enjoy it.
Also on Fridays they have a free coffee ceremony.
Oh yeah, they do.
Yeah.
I got it.
Both the Bana is 100% plant based.
Yeah, I love butter. Well, literally, I got it last time we were here. I just put it in and I'll grab it. So if the professor's 15 minutes late to class, then the class is canceled.
No,
Sure,
no,
I won't be late.
Whatever professor.
I did cancel class one time though because I was running late.
And once you did a Zoom call while driving from Boston to Amherst.
Oh, that checks out, yeah.
Yeah.
But that was for office hours though. That was different.
No, there was a lecture, right? No,
I would not have given a lecture while driving. I could have done a lab.
or like an exam review, like exam.
Oh
review.
yeah, that's possible. That's totally possible. Well, because okay, with the exam reviews, because I had kids students all over the fucking world. Some of y'all motherfuckers were requesting me to do exam reviews at like fucking 11 p.m. like Saturday, which I was
You don't
willing
have
to
acknowledge
do.
that. You don't have to acknowledge that.
I was willing to do, but at the same time, I have a life.
Yeah.
So
No,
you know,
you're not bound to that. Obviously. I think you can still do it. Like for example, every office hours that I did was like at 3 a.m. or so. I just came for 3 a.m. office hours.
no, yeah, that's fair. Yeah, I had office hours at the weirdest fucking times and exam reviews at the weirdest times. But
Crazy.
okay, so we are getting into the last like 15 minutes of lecture. If you are willing to tolerate spoilers, I will put up the answer. If you guys don't want spoilers and none of you want spoilers, I will just code it after stopping the recording and turning off the screen share. Or not stopping off it's not stopping recording, but I will code it. And I need everyone to just close your eyes. Sorry, I do have to code it on there in order to keep the recording going so we can get the answer on there. Okay, but yeah.
Well, are you hungry?
No. Well, we're about to have sushi.
But I don't want to. I know I eat a lot. I can help this. I guess I'm sorry with the butter. I'm trying.
Well, no, I encourage you to keep trying.
You got this. I don't need a feast. Not this fish thing. No, that's. I'm just looking at the same.
So you're just using his friend? Oh, sorry, you're just naming the boolean as prime.
Yeah.
I thought you-
Oh no, I'm not using math.prime.
Yeah.
That would be cheating, in my opinion.
There's for her. Ugh.
Short of what?
Lena, you could always just use ChatGPT if you really wanted to cheat. The point is to have practice.
Also, ChatGPT these
Look
days
at
is
this
like
far
perfect
line.
at this
I
kind
I
made
of
this
know.
far line.
ChatGPT could do this pretty easy.
like 2 years ago, ChatGPT could not do even this probably. Like 60% of that. To thought of somewhere.
Oh, you're not staying for sushi?
I'll see.
Okay.
Because I'm meeting
She hates
my
me.
friend
Oh,
or it's like okay, we're just leaving on Monday.
mhm.
Even though she just got it all her. She hates me.
Thank you. Okay. I think this is it.
But surprisingly, I never went to class 5.
But right now you are.
Yeah, this is not a real class.
This is a real class.
This is the end of the
Respect
class.
the-
This is
respect
the
the-
end of the class.
This is real as it could get.
No, I think if
Well,
if we
that
were
was not
actually in
right.
school, like if there were other students, I would not be hired. But I would sit in the back and play games. I usually play League in class.
Oh, right, because I can't start with 1. That's okay. Cool. Okay. It works.
Oh, but you're not gonna do the X times X.
Hmm?
Like number. Like
Well, I mean, because it is 2 times 2 times 5 times 5. That's 100, right? And if I wanted to go through like,
I thought this entire time you wanted us to print it with 2 times 2 times, like with the.
okay, fine, I'm here.
No. That's okay.
It's like not even.
No,
any
no, you know what? Here,
There's not much.
output plus
There's not much
equals.
difference. Because the
Um,
whole magic is in getting the numbers, not like how
Right.
you use it.
equals plus I plus
My mind just couldn't comprehend that.
Okay, what?
Like this. I was like, I can't think of
You
this word.
were like acing that last week.
Yeah, but like this week I was in my
You're
brain.
asking
Yeah.
good questions on Zoom. Don't undersell yourself.
Oh no.
Yeah.
Because when I got out of when I got out, I couldn't slow while driving. I was slightly locked in, but I was still driving.
Edibles.
Yeah, you're so right. That's okay. It's time to wake up, so I myself.
Ta-da! You happy, Lena?
Yes.
That admittedly does use some things I didn't teach you guys yet. But
Yeah,
okay.
that's why my brain was like, I cannot think about it. I was like, that
but
was
you have to
just too
represent
much.
it as 2 raised to 2 raised to 2 times 5 raised to 5. That's
Yeah,
5
yeah,
to 2
yeah.
or something.
But yeah, there you go. That is the answer. So here, let me fix these comments now that I have actually coded it properly.
I'm scared. I'm so about this.
You need help? Yeah.
There we go. That is the code answer if anybody wants it. But if you're still trying to figure it out yourself, continue. It's worth it. If you're feeling lost, I can give you guys an easier challenge. Hmm.
But like that's an oxymoron. What do you mean?
Okay, yeah, I'll give you guys an easier one for the take-home project. But yeah, so I think that'll be it for the in-class one. I'm typically probably going to make the in-class ones a little bit shorter, but a little bit harder, just because I am, Himanshu and I are going to be here to, answer any questions you may have. But then take-homes will be, a little bit longer, but a little bit easier. So I will assign that probably later tonight or early tomorrow morning. And I will see you all next week.
All right, thanks,
Bye-bye
Paul.
for now.